Good morning. Now we are doing some more problems in graphical method on solving LPP problem. So the LPP mathematical model says like this. So the objective function is to maximize z is equal to 5x plus 4y subjected to the constraints given here. 6x plus 4y is less than or equal to 24. So then we have x plus 2y is less than or equal to 6. And then minus x plus y less than or equal to 1. Then we have y is less than or equal to 2, and the variables x and y will take any value greater than or equal to 0. So taking the first constraint here, 6x plus 4y. So the constraint is less than or equal to, we are making it as equal to 24. So one single equation with two unknowns x and y. So either x will be made 0 or y will be made 0. So if y is made 0, x value is 4. So 6 4s are 24. So 4 comma 0. So if x is made 0, so it is 4y is 24. So y will be 6. So it is 0 comma 6. Then the next constraint, so that is x plus 2y, so less than or equal to will be made equals to 6. So here also by making x as 0 or y as 0, so the coordinates will be now 6 comma 0, 0 comma 3. Then we have the third constraint, so that is line number 3. So minus x plus y is equal to 1. So if x is made 0, y becomes 1. If y is made 0, it is minus x is equal to 1. So x is equal to minus 1. So it is minus 1 comma 0 and 0 comma 1. So then the fourth constraint, y is equal to 2. So naturally x will be 0 if y is equal to 2. So it is 0 comma 2. So we have 4 constraints here. So in the form of 4 lines. So 4 lines are there. So we have to plot the graph now. So first is 4 comma 0, 0 comma 6. So we are making here the two lines x and y. So on x-axis, so that is 4 comma 0. So that is I am taking here 1 centimeter is equal to 1 unit. So the first point on x-axis 4 comma 0. So 4 comma 0 is taken here on x-axis, and then the other point on y-axis is 0 comma 6. So 0 comma 6. So 0 comma 6 here. So that is taken 0 comma 6 here. So 4 comma 0 here on x-axis and 0 comma 6 on y-axis. So join the 2 points to get the first constraint. So then it is 6 comma 0, 0 comma 3. So on x-axis it is 6 comma 0 here, and on y-axis it is 0 comma 3 on y-axis. So 6 comma 0 on x-axis, 0 comma 3 on y-axis. The 2 points are joined. So then it is minus 1 comma 0, 0 comma 1. Minus 1 comma 0. So we want minus 1 on x-axis. So going to the left of y-axis. So minus 1 comma 0 on x-axis and 0 comma 1 on y-axis. So here is 0 comma 1 on y-axis. So the 2 points minus 1 comma 0, 0 comma 1 joined and extended. Then the last point 0, 2. So it is on y-axis 0, 2. I am drawing a horizontal line. So 4 lines are obtained now. And the constraints are all of them are having less than or equal to. That is the inequality, less than or equal to. So I have to restrict my area satisfying all the 4 constraints. So I have to take the area such a way that it is within the boundary, that is here it is 6x plus 4y less than or equal to 24. So coming to the first line 6, 0, then it is 0, 3. So I have to take the area below the line. Similarly, for other lines also, I must take the area such a way that it is not, the area taken is not extending any of the 4 lines. If the constraint is greater than or equal to, then I have to consider the area above that particular line. But all of them are having the constraint less than or equal to. So here the area that is hatched, the feasible region considered is within the lines drawn. So that is satisfying all the 4 constraints. So I have this hatched part, that is the feasible region. I have the 4 corner points here starting from the origin 0, 0. So the vertices 0, 0 here. The objective function, okay, is this. So substituting x and y as 0 and 0, z value is also 0. Then we have the corner point, so that is 4, 0 on x-axis. So substituting 4, 0, that is this point. So 4, 0, substituting x 4, y is 0. So z becomes 20. Then point A, so that is having the coordinates 3, 1.5. Substituting x and y, we are getting z is equal to 21. Then the next point, corner point is B here. So having the coordinates 2, 2. Substituting x and y as 2, 2, we are getting 18. Then point C with the coordinates 1, 2. So that is having a z value 13. Then 0, 1. So that is the another last corner point here, 0, 1. So substituting 0, 1, z value is 4. So out of this, so z is maximum, that is 21, which occurs at A, that is 3, 1.5. So that is the optimum solution which maximizes my z. Thank you, friends.